All right, so we'll see some questions related to the properties, okay? So let's go to question number one. It says log of 125 to the base 2 divided by log of 5 to the base 2, okay? So what we can do here is we can use base changing theorem here, right? And it's going to be log of 125 to the base 5, right? Because what we have used here, uh, base changing theorem, and which says log m to the base a by log n to the base a is log m to the base n. So now you can think, what does it mean? It means that to what exponent should we raise this 5 to get 125 as our answer? So the answer is 3, right? Now let's go to question number 2. I hope it is clear, right? Now go to question number 2. If you look at question number 2 now, this thing and this thing to me looks quite familiar, right? What if I do something so that if 3 goes here and 7 comes here, this thing is sorted out, means this thing will cancel each other. So we had one very nice property which we call exchange property, and which says that a raised to log c base b is equal to c raised to log a base b. Okay, so we are going to use the same property here. So it's going to be 7 raised to power log, and here 3 to base 2 minus 7 raised to log 3 base 2 plus 1. So it will get cancelled. 1 is your answer. Okay. And the next is 2 raised to this. Now see here, if you look at this thing, we have the common base. So here, what we can do, we can use BCT, base changing theorem here. So if we use base changing theorem, it would be 2 raised to log 7 7 and here base 2, right? And this is very similar to what we did what we did yesterday, that is a log ba, which is b, right? So this is going to be 7, right? So 7 is going to be your answer. Okay, this is one of the principal property of logarithm. Okay, so it says that if your a is raised to the power log of b to the base a, then something happens that cancels these things and it will be left with b, right? Now go to next, number 4. 1 by log 3 to the base 81. Now see here, this 3 to the base 81, what I can do here is, here this can be written as log of 81 to the base 3, right? What I used here, I have used here 1 over log b to the base a is log of a to the base b. Okay, so this is the implementation of base change property. This is also the principal property of logarithm. Okay, so now here, to what power should we raise this 3 to get 81 as your answer? So the answer would be 4. Okay, now go to the next, 125 raised to the exponent log 2 base 5. Okay, this thing, what we can do here is, what if this goes here and this comes here, right? So we can use which property here we can use this property, right? This property, using this property, what would happen? It would be 2 raised to log 125 to the base 5, right? And and uh, it means to what power should we raise this 5 to get 125 as our answer? So the answer is 3, so it's going to be 8, right? Then next, 49 raised to the exponent 1 by log 7 base 5. This can be written as here log 5 base 7. Why? Using this property, 1 by log b to the base a equals log a to the base b. So this thing is simplified as here. Now, what I can do, see here, things will get sorted if 5 goes here and 5, sorry, if 49 goes here and 5 comes here, right? And so it would be, we can make use of this property. So it would be here 5 raised to log uh, 49 base 7. Now this is 2, this thing is 2, so 5 raised to power 2, it's 25, right? It is 25. Okay, now go to the next, log of 2 to the base 512. And now what we can do here is 512, I guess it's 2 raised to power 9, right? So it can be written as log of 2 to the base 2 raised to power 9. Now, you remember this property, wait, it will be 1 by 2 log 2 to the base 2, which is 1 by 9, right? Now, what property did we use here? It's a base power property, which says that log of here log of b to the base a raised to exponent k, it should be 1 by k log b to the base a, this property. Okay, so 1 by 9 will come here outside, and here inside will remain this log 2 to the base 2, which is 1, right? Then the next is this. Okay, now this thing, what I feel, this whole thing can be simplified as 1 by log 2 base 3, log 2 base 3. It can be written as log 3 base 2, right? Plus 2 times log 9 base 4 minus 3 log 27 base 8. Okay, is it visible? Yeah. Okay, what I did here, I just made use of the property 1 over log b base a is log a base b, this property. Okay, now what would happen here? It would be log 3 base 2, and this one would be, now see here, this one is log of 3 raised to power 2, a base 2 raised to power 2, so it will be plus 2, and it will be 2 divided by 2 log 3 base 2 minus 3, and here again 27 is 3 raised to power 3 and 8 is 2 raised to power 3, so minus 3 times 3, again here log 3 base 2. Okay, it will be cancelled. So what will be remain here, log this is log 3 to the base 2 plus 2 log 3 to the base 2 minus 3 log 3 to the base 2. So 2 plus 1, 3, 3 minus 3, 3 minus 3 is 0. So the answer is going to be 0, right? I hope this is clear to you. Okay, now come to the next one. I can make some space here on the left side. Okay, quite easy questions if you know the properties. Okay, we did nothing. We just made use of properties, right? So come to question number 9. Question number 9 says log 12 to the base 3 divided by log 3 to the base 36 minus log 4 to the base 3 divided by log 3 to the base 108. Okay, now see here, we can see one thing, that the base is not same, so we have to do something to make the base same. So what I can do here is we can make base 3 here. Okay, now in the numerators I have base 3, but in denominators I have different bases, right? So what I will do here, if see here, log 12 to the base 3, and here I can write this one. This thing can be written as, log of 36 to the base 3. I have used the property. Which property? 1 by log b to the base a is log a to the base b. Okay, so I have made use of this property. Here again, log 4 to the base 3, and this one same, log 108 to the base 3. Again, the same property I have used here. Okay, now you can see one thing. Now my base is same, so I can simplify it more. So here, a log, this thing can be written as 12 log 4 multiplied by 3, here base 3, and this thing can be written as log 4 times 9. So this is 4 multiplied by 3 square, base 3, minus this is log 4 to the base 3, and this is log 108 is 27 times 4. So this would be 4 times 27. Okay, base 3, right? Now let's simplify it. Now we can use the product rule here, which says log mn is log m plus log n. So it would be log 4 to the base 3 plus log 3 to the base 3. Then here again, product rule, log of 4 to the base 3 plus log of, now this is log, this would be 2 log 3 to the base 3. Why? Because log of 3 squared to the base 3 is, it's quite similar to log of x, and that is n log x, right? So I made use of that property here. Then this one would be log 4 to the base 3, again product rule here, so it's going to be log of 4 to the base 3, and here plus 3 log 3 to the base 3, right? Now you can see we can do few things here. This is going to be 1, this is going to be 1, so it's going to be log 4 to the base 3 plus 1, and this is log 4 to the base 3 plus 2 log 2 log 3 to the base 3. It's going to be 2. Why? Because log 3 to the base 3 is 1. Then here log 4 to the base 3, and it's going to be log 4 to the base 3 plus 3. Okay. Now this thing log 4 to the base 3 is appearing lots of times here. So what we can do is put log 4 to the base 3 equals n. So if I put it n, so it's going to be n plus n plus n plus n plus 2 minus n minus n n plus 3. Okay, so it's going to be 2n 2n this is going to be 2n plus 2 minus n square minus 3n. Is it correct? Here, okay, this bracket here, bracket, and this thing log 4, this bracket here, right? So it should come as a bracket, it should appear as a bracket, right? So this is n plus 1, n plus 1, n plus 2, n plus 2, and here minus n plus 3. Okay, so if we simplify it, it's going to be n square plus 3n plus 2 minus n square minus 3n, right? So it will be cancelled. So 2 is going to be your answer. 2 is going to be your answer. Okay, so I hope this is clear to you. Write one more question. Write one more question here. Okay, quite easy questions. And just you need to you just need to put one thing in your mind, that these properties are very important and you have to memorize all, and then you will find these questions very, very easy. Okay, so next question says, question number 10. Question number 10 says that, let log a to the base b equals 10, then find log b to the base a plus log a square to the base b square plus log a cube to the base b cube, so on, log a raised to power 10 to the base b raised to power 10. Okay, so this is the thing given to you. Now see here what we can do here. We are given with this, we have to find this, so this would be log of b to the base a plus, now see here, this power will come outside 2, and the base power will come as 1 by 2, so it will be 2 by 2, and here log of b to the base a. What property did we use here? First, log of x raised to power n is n log x, and then log of x to the base a raised to exponent k, that is 1 by k, log of x to the base a, right? So here same, 3 by 3 log of b to log of uh, this is log of a to the base b, right? So it's going to be a to the base b here, a to the base b here, a to the base b, so on, and here would be 10 by 10, right? 10 by 10 log of a to the base b. Okay, so this whole thing means that it will get cancelled. So how many times? 10 times. So it would be 10 log of a to the base b, right? And log of a to the base b is 10, which means that this is 10 multiplied by, because this thing is 10, it's given, so it's going to be 100. Okay, so that's how you have to solve these questions. Very easy, just memorize the properties. Okay, so I hope these questions, they have expanded your horizons. Okay, and now you know like how you have to approach the problem, and then how, and you have to think about how this problem could be simplified further. Okay, so that's it for today, and we'll see you next time with the next video. Thank you very much. Bye bye.